You could imagine that the oceans are actually the largest battery. We're storing huge amounts of energy in the oceans. The wave motion can be very deep. It can extend down several hundred meters. And once it gets to the near shore, from about 50 meters, the whole water column is moving backwards and forwards.
As we search for ways to reduce our reliance on fossil fuels, some are looking to a largely untapped potential source of renewable energy. In theory, waves off the coast of the United States alone could generate over 2 trillion kilowatt hours of electricity a year, enough to power more than half of the country.
Waves intensify and subside not as quickly as the wind, and that means that it can produce a smoother power generation curve. One of the potential advantages of wave energy is that it could act as a complementary source of power compared to other renewables on the grid if it were to be scaled up to commercial scale.
For decades, engineers have been trying to convert wave energy into electricity, but a host of technological and financial challenges have complicated their efforts.
In the years from around 2006 to 2015, there were a spate of bankruptcies in the sector, and this was largely because of a lack of kind of continuous proven projects out at sea with reliable electricity generation.
Since then, companies have been trying to develop the technologies at a steadier pace and with a smaller cash burn. But the same questions remain. Can companies develop devices and technologies that actually work? Is wave energy just a novelty or something that can become a major renewable energy source?
The sea is a very challenging environment within which to operate a power project. So seawater is corrosive and conditions are very rough. So this means that power projects don't have a very long lifetime, and it increases operating and maintenance costs.
Partly because of that, many early wave energy projects hit rough waters, such as the Pelamis Wave Energy Converter in Portugal and the Isla Limpet project in Scotland. But that hasn't stopped others from trying.
Companies are focused on testing projects out at sea, proving their durability, trying to raise capital and bring down cost. The sector hasn't really converged around one single technology design, and companies are kind of undecided about which design works best.
Finland-based AW Energy is a veteran in the sector. The first proof of concept of the company's device was made in the 90s after diver Rauno Koivusaari observed the strong back-and-forth movement of a hatch cover in a shipwreck in the Baltic Sea.
The waves are generated far from the coastline, so the wind blows on the surface of the water, causing the water particles to rotate. And that rotation extends deep down below the surface, and the waves can be very long. They can be several hundred meters long. And as they come into the near shore, this rotational energy turns into an elliptical energy, and eventually backwards and forwards, as you probably noticed if you've been swimming on the seashore in large waves, you're pulled in and out. That's the energy that we're extracting. There's a sweet spot where we deploy, so around 10 to 15 meters of water depth. That's where there's still strong wave energy coming in.
After years of research, prototyping and testing, the company has deployed WaveRoller, a 350 kilowatt device in the waters off Portugal. WaveRoller has an 18-meter wide and 10-meter high steel panel fixed to the seabed via a floatable foundation. The panel moves back and forth with the waves, capturing the energy.
It's submerged in the depth of 15 meters, so it's protected from the extreme waves. We generate electricity by capturing the movement with hydraulic circuitry in a machine room underneath the surface. That hydraulic energy we turn to electricity with hydraulic accumulators and hydraulic motors, and also a generator.
The WaveRoller has survived large waves at sea for over a year and delivered electricity via an underwater cable to the grid in Portugal. Meanwhile, the company has won a €2.5 million grant to work on an upgraded version of the wave roller, aiming to increase the electricity generation capacity to 1 megawatt. The upscaled device would have a bigger panel, 2 power takeoff units, and improved software to control the energy production.
We have taken into use a wave prediction algorithm that kind of tells us what kind of waves are coming in to our device. That gives us few seconds to prepare for capturing more energy, and the difference in that is significant.
Our future plans are to deliver technology around the world. So I'm hoping we can be working on delivering technology to projects in Asia and also in the American continent as well.
Meanwhile, Israeli company Eco Wave Power is taking a different approach to capturing the power of the ocean. For the company's founder, Inna Braverman, developing new sources of renewable energy is a personal mission.
I was born in Ukraine in 1986, and 2 weeks after I was born, the Chernobyl nuclear reactor exploded, causing the largest in history nuclear disaster. I was one of the babies that got hurt from the negative effects of such explosion. I had a respiratory arrest and a clinical death. Luckily, my mother, a nurse, approached my crib on time and gave me a mouth-to-mouth resuscitation, which saved my life. I got a second chance in life and decided to do something good with it.
Growing up, Inna wanted to be a politician to positively change the world. After working as a translator at a renewable energy company, she decided to change paths.
Solar and wind energy were fully commercialized. There were a lot of amazing technologies implemented everywhere. I saw that wave energy, although it's an immense source of electricity, the biggest companies in the world are trying to develop wave energy with no success. And there was kind of a race going on in the world of who is the company that is going to develop a viable wave energy solution first.
In 2011, the then 24-year-old Inna co-founded Eco Wave Power. Instead of installing devices offshore, the company's devices are attached to existing breakwaters, jetties and piers.
Our technology is very cost efficient, especially in comparison to the offshore technologies, because we don't need any ships, divers, underwater mooring or cables. We install on existing man-made structures, and all our expensive equipment, the generator, the hydraulic conversion unit, the automation, is located on land just like a regular power station. This is the EcoWave Power conversion unit that has been operating in Jaffa port since 2014 until 2020. Here you can see how the technology works. Basically, the floaters are going up and down and pushing the hydro cylinders, which transmit biodegradable fluid into land-located accumulators. A pressure is being built. The higher the waves, the higher the pressure, which is used to turn the hydro motor, which is turning the generators. The whole system is controlled by a smart automation system, which you can see right here. And in case of upcoming storms, the system automatically raises the floater above the water level and keeps them in the upward position until the storm passes.
The company has been operating a 100 kilowatt grid-connected device in Gibraltar since 2016, which is enough to power 100 households. Currently, Inna and her team are working on another 100 kilowatt project at the port of Jaffa in Tel Aviv.
The project will be also the first time in the history of Israel that wave energy will officially connect to the electrical grid. And our goal going forward is to expand it to all suitable breakwaters in the city of Tel Aviv and to supply a significant part of the city's electricity needs.
Today, engineers and entrepreneurs are still trying to crack wave energy. Globally, only a few hundred kilowatts of wave energy are deployed, compared with gigawatts of offshore wind. But the field has come a long way in recent years, and with the right engineering solutions, this new power source could eventually become competitive with more mature renewables like solar and wind.
I would have a lot more confidence in the successful wave energy companies today as opposed to like 20 years ago. But in the next few years, or maybe the next couple of decades, it will be more likely to be used in remote locations like islands that are otherwise dependent on expensive diesel power, or out at sea on gas decommissioning rigs, or for powering underwater autonomous vehicles.
So definitely wave energy can compete with other renewable energy sources, but I personally believe that this is not a competition. In order to have a 100% renewable energy friendly world, we need all renewable energy sources to work together.